Section 5.2 finds us looking at a specific type of sequence called an arithmetic sequence. And you might be saying, wait, are you saying that wrong? Isn't it arithmetic? Well, when it's used as an adjective in the math world, it's actually arithmetic. So this entire section today is going to focus just on arithmetic sequences. Now, here's the good news. If we're dealing with a specific type of sequence, that means mathematicians, knowing how much they love their shortcuts, have developed formulas to help provide answers quicker. Because if it's a specific type of sequence, there's certain things that will happen every single time. So all of our objectives today involve becoming more familiar with arithmetic sequences and how they work. So let's take a look at it here. So when I say an arithmetic sequence, what makes it arithmetic, you are adding by some value to get from one term to the next. And remember, each number in a sequence is called a term. So a lot of my students will remember this by arithmetic and add both start with A. The value that you add by each time, this number that you're adding by, is referred to as the common difference. And in formulas today, it's going to be represented by the variable d. So, example of what I mean by this. Suppose I had this sequence. Okay, it's an infinite sequence. Keeps going. If I asked you to tell me what is the pattern here, what are they doing each time, you should hopefully be able to spot, hey, they added 4. Hey, they added 4. Hey, they added 4. If they are adding by the same number every single time, it is an arithmetic sequence. And on this problem, since they're adding by 4 each time, I would say the common difference is 4. That is the number they are adding by each time. Now, what sometimes people find a little goofy is, why is it called the common difference? Because difference deals with subtraction. Why isn't it called like the common sum since we're technically adding? Well, it's called the common difference because if you're not sure what they're adding by, to find the common difference, you can always take one number and subtract the number that came before. So I could have did 11 minus 7 and got 4, or I could have did 15 minus 11 and got 4, or 19 minus 15 and got 4. If it's arithmetic, it does not matter where you subtract, you should get the same number every time. But you're always taking one and subtracting the one that came before. That's why it's called the common difference. So, let's look at this first example here. Write the first 6 terms of the arithmetic sequence in which a sub 1 is 6, and then it gives me a setup for the sequence. So I already have my first answer, but I'm going to write the first 6, so I need 5 more answers. So let's talk about if I want a sub 2. How would we find this? Well, this lovely guy, when the sequence is written in this form, this is a recursive formula, which we talked about last time. Remember, the recursive sequences always use the previous term to get the next thing. So if I want to find A2, notice the 2 is sitting where the n is. So we're going to plug a 2 anywhere that we see an n. If I simplify this, that becomes a sub 1 minus 2. So now I have to use my previous answer. A sub 1 was 6. So I'm going to be doing 6 minus 2. So my second answer should be 4. Now let's find a sub 3. Since 3 is now sitting in the spot of n, I want to plug a 3 in anywhere I see n. So it becomes a sub 2 minus 2. So our previous answer, a sub 2, was 4 minus 2. I get 2. So then a sub 4 I'm going to use my previous answer. So it becomes 2 minus 2. At this point, if you can spot the pattern, it would probably be easiest just to finish listing them. Notice it was 6, 4, 2, 0. They're going down by 2 each time. So a sub 5 should be negative 2, and a sub 6 should be negative 4. Now you might be asking yourself, wait a second. If this is an arithmetic sequence, I thought we had to be adding each time. And it looks like we're subtracting each time. Well, yes and no. We're going to think of it as we were adding a negative 2 each time. Okay, so we will be working with negative numbers. So it's still arithmetic because I can think of it as I was adding a negative 2 each time. All right, so since we have a specific type, we have a formula for this that will help us get or generate terms in the sequence. So my formula for an arithmetic sequence is a sub n equals, and this will allow me to plug any number I want in for n. I take a sub 1, which is my starting term, plus the quantity n minus 1 times d. So in this formula, a sub 1 is the first term, n is the number of terms, like how many you would have, and then d is the common difference. In other words, what are they adding by? So let's see if we can do this one. Write the first 6 terms of the arithmetic sequence in which a sub 1 is 200 and d is negative 60. So they gave me the first answer. So now let's just think about it. To get a sub 2, you don't need a formula. If they told you what they're adding by, you should just be able to generate the list. So I want to add negative 60 to 200. If I do that, my second term comes out to 140. If I want the third term, I'm going to add negative 60 to 140. I get 80. So if I keep adding negative 60, I can keep generating each new term. So you might be asking yourself then, what's the point of the formula if we can just do it that way? Well, the formula can be a time saver, which we'll look at in the next couple of examples here. So write a formula for the general term, the nth term, of the arithmetic sequence, and then it gives me the sequence. So sometimes these directions confuse people on what it's asking you to do. If they ask you to write a formula for the general term or the nth term, we are going to write our formula, but we're going to keep in terms of n. In other words, I'm not going to substitute anything in for n. I'm going to keep it as n. I want a general formula. So real quick, let me write down, here was our formula. So let's see what we can substitute in. So a sub n equals, what would I substitute in for a sub 1? Well, it's my first term, and the first term in my sequence is negative 2. I'm leaving n as n. And now I need to know the common difference d. I need to know what are they adding by. So again, if you can't just visually tell what are they adding each time, you can always take one of the numbers, so if I take the 18, and subtract the one that came before it. So that tells me the common difference is 10. They're adding 10 each time. The last picky detail, I would just like you to simplify this formula a little bit. So a sub n equals negative 2. I'm going to distribute my 10. So plus 10n minus 10. And then I'd like you to combine like terms. So my formula, my general formula is 10n minus 12. It's called the general formula because now I can substitute in any number I want for n and get an answer. So, and that's what this second question is going to ask. Use the formula for a sub n that we just made to find a sub 15. A sub 15 represents the 15th term in the sequence. So if I kept listing my numbers of the sequence out, I want to know what is sitting in spot 15. Now it could take a while if I just kept adding 10 each time. I could do it that way. I could just keep adding 10 until I get to spot 15. But it might be quicker just to use the formula. So I'm going to plug 15 in for n. And now I want to evaluate this and see what number comes out. So if we do that, we would get 150 minus 12. I think that's 128. No, 138. 150 minus 12. Yeah. So what does this mean? It means if I took my sequence and I kept listing my numbers out, when I get to spot 15, that number would be 138. That's what that answer represents. So the formula can be a time saver. So look at this next example. Find the 68th term. So they give me the sequence. I want to know what is the number that would be sitting in spot number 68. So we definitely want to use the formula because it would take forever just to list everything. And this time, since it doesn't want me to write the general formula, I'm just going to substitute in for n right away as well. So what do I want n to be? Well, I want the 68th term, so n is 68. What's a1? My first term is 25. We said n was 68. And the common difference, I have to figure out what are they adding by. So again, if you can't spot that, take one of them and subtract the number that came before. So it turns out the common difference is negative 8. And so now we can do all of this simplifying and we will get our answer. So if you do all of that multiplying and adding, you should get negative 511. So what that means, if I continued listing my numbers out of my sequence, when I get to spot number 68, that number would be negative 511. And if you think about it, this answer makes sense. Notice my numbers are decreasing. By spot number 3, I was already down to 9. So it makes sense that by spot number 68, I'm going to be way into the negative numbers. Okay, the other part to today's lesson is something called a series. When you see the word series, I want you to bring to mind the sigma symbol. And last time we talked about the sigma symbol means sum. It means we are adding up all of our terms. We're getting like a grand total. So whenever you see the word series in math, I want you to think we're going to get a total. We're adding everything up. So since this is a specific type of series, it does have a formula to get the grand total. An example of where you would see this applied, let's say if I had an auditorium and I needed to figure out the capacity, maybe row 1 has 10 chairs, row 2 has 13 chairs, row 3 has 16 chairs, and it goes all the way up for 150 rows. And I want to know what is the total number of chairs that this auditorium has. That is an example of a series. I would be taking like a grand total of all of my rows. The formula for this, the sum, so S sub n, is equal to n divided by 2. And then in parentheses, we have a sub 1 plus a sub n. Before I forget, people always ask me, are we responsible for memorizing these formulas? And my answer is no. On the test, you will be given all of these formulas. You just have to know how to correctly apply them. So in this formula, n is the number of terms, just like it was in the other formula. A sub 1 is my first term. And a sub n, I want you to think of it as the last term. So it's kind of like start to finish, first term and last term. So it's not a difficult formula to use. Let's try it. Find the sum of the first 100 terms of this arithmetic sequence. So what this means, if I started listing these numbers, and I kept going until I get to spot 100, whatever that number may be, since I want the sum, what I would do at the end then is I would add all of these numbers up. So this answer could be pretty big. Now that's going to take forever to do by hand, so we're going to use the formula to speed things up. Off to the side, let's see if we can identify the information that we will need to use this formula. So a sub 1, what is my first term? Well, the first term in the sequence is 1. Great. N, the number of terms. How many of them would there be? If I were to physically count these numbers, how many of them would there be? Well, I know there's going to be 100, because it told me in the example I want to do 100 terms. And what people have the hardest time with is a sub n. I want to know what is that last term. A typical wrong answer I will see, people will tell me, well, it's 100. No, don't get confused. There's 100 terms. I want to know what is sitting in spot 100. It's not 100. I want to know what is sitting in that spot. So the question is, how do we get that? This is basically what we want to do. I want to find a sub 100. I want to know what is spot 100. That's my last term. So to do that, what you're going to see a lot of the times, we have to quick use the first formula before we can use the formula we want. So let's substitute in, let's find what is this mystery 100th number. So a sub 1 is 1, n is 100, and my common difference, what am I adding by each time? 2. So if we do that math, the subtraction, the multiplying, and the adding, it turns out it comes out to 199. So that is my ending term. That is what is sitting in spot 100, 199. So now, finally, we'll end the problem and actually use the sum formula. So the sum of our 100 numbers, so 100 over 2, and then a sub 1 is 1, and my a sub n, which is the 100th term, we said was 199. So if I simplify this, that's 50 times 200 I will get my answer. And it comes out to 10,000. So what does that answer represent? Well, if I added up all 100 numbers, they would total to 10,000. Let's look at another one. Find the sum of the odd integers between 30 and 54. Let's see if we can identify the three things we'll need. So the odd integers. So remember, an integer, when we see that word, that's like this. So no decimals, no fractions. And if I want them to be odd, for example, between 30 and 54, the first number that would be an odd integer is 31. And then it would be 33. And then 35, dot, 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 up until what would be my last integer? You should say 53 would be the last odd integer between 30 and 54. So I automatically know my first term of this sequence is 31. That's the number I'm going to start with. And I also know the last term. I know the last number in my sequence is 53. The kicker on this one is figuring out n. How many of these things would there be? Sometimes people are tempted to say, oh, 53. No, 53 is the last number in the sequence, but I want to know how many of them are there. So how do we do this? Well, one way you can think about it, if I were to subtract 53 minus 31, what does that come out to? Well, that comes out to 22. But I want to divide it by 2 because I only used the odd numbers, right? So there's 22 numbers between 31 and 53, but I'm cutting it in half because I'm only looking at the odds. So you might think, oh, there's 11 numbers. This is probably the trickiest thing of the whole lesson. There's not 11 numbers. There's actually 12, one higher. And you might say, why? Why is it one higher? Let me show you an example here. You don't have to write this down. If I gave you these numbers, and I said, how do I want to word this here? If I said, no, I don't want to do that. If I physically did this, this will be better. Let's say I counted from 1 to 5. Great. If I asked you how many numbers in blue have I written down, you would tell me you wrote down 5 numbers. And I would say yes, absolutely. If I wanted the quick way of figuring that out, if I did 5 minus 1, I would get 4. But we can see there are not 4 numbers. There's 5. It's 1 higher. Why is that? Well, when you subtract, it doesn't count the first number. So anytime today, if you're finding n and you do it from subtracting, just know n is going to be 1 higher. So that's why n is 12. We'll do another one if you're still fuzzy on that. Now that I have everything I need, I'm going to find my sum. So the sum of these 12 numbers, I would take n over 2, so 12 over 2, and then in parentheses my a sub 1 plus my a sub n. So this would be 6 times 84. And I get 504 for my total. Let's try another one of those. Find the sum. Now on this one, I wouldn't have even had to give you the directions because remember, if you see the sigma symbol, that literally means we are going to find the sum. Now last time what we did when we did this, we put in 1. So if I substitute 1 in for I, 5 times 1 is 5 minus 9. I'd get negative 4. Then we put 2 in. 5 times 2 is 10 minus 9, 1. Then we put 3 in, and we did that all the way up till the last guy. If I put 25 in, 5 times 25 is 125 minus 9. I really don't want to substitute in 25 numbers and then add them all together. That's going to take forever. Last time it wasn't a big deal because I didn't have you go too high. So how can we speed this up? Well, we're going to use our formula to find the sum. So let's see if we have everything we need to do this. A sub 1. What is my starting term? Now, so careful here. People will tell me 1, because that's what's on the bottom, 1. That does not represent the starting term. That tells me what I'm going to plug in to get the first number. So if I plug 1 in, notice I got out negative 4. That is the starting number. Now n, how many of them would there be? Well, if I'm going from 1 all the way to 25, if we take 25 minus 1, that's 24, but then you need to think 1 higher. If I were to list these numbers out, there would be 25 of them. And it makes sense, right? I'm starting at 1 and going to 25. There's 25 numbers. And finally, what would be my ending term? Well, to get the ending term, sometimes people will tell me, oh, it's 25, because that's what's on top. No. That means I'm going to spot number 25. So to get that number, you plug 25 in. And when I plugged 25 in, I got 116 out. So the 25th number is 116. So now let's find the sum of these 25 numbers. Okay, if we were to do that simplifying in the calculator, what you should get out for your sum is 1,400. Okay, and let's end with one application. Your grandmother has assets of $500,000. One option that she is considering involves an adult residential community for a 6-year period beginning in 2018. The model A sub n equals, and then it gives me this sequence, describes yearly adult residential community costs n years after 2017. Does your grandmother have enough to pay for the facility? So, what do they want me to find? Well, let's see what we're dealing with. I have my sequence, and this is n years after 2017. We're also dealing with a 6-year time frame. So if I want to deal with money over 6 years, our goal, we're going to be using the sum formula because I want to find like a grand total. And once I have this grand total, I'm going to compare it to how much money she has, and that'll tell me if she has enough or not. So let's see if we can identify the things that we will need. So A sub 1, I need to know what is term 1. And you might say, well, it's 1. No. I want to start at term 1, so how would I figure out what A sub 1 is? Well, we have to plug 1 in for n. So if we do that simplifying, we have 65,000 930. That's my starting amount. N, how long am I going to do this for? How many would there be? Well, you should say N is 6. There's going to be 6 years. And now A sub N, what does that represent? You might say, oh, it's 6. No, I want to go to spot number 6. So how would I figure that out? Well, we have to plug 6 in. I want to know what would be happening on year 6. If we do that, simplifying, 74,930. Now we're ready to find the sum. So the sum over these 6 years, I'm going to take my starting amount plus my ending amount, and I want to simplify that. If you do that math, this is the amount of money that comes out. So what does this mean? What does this number represent? This would be her total costs over the 6 years. So does she have enough? Yes, she has 500,000, so she would have enough to make this work. So Granny's gonna be living good.